Okay, so let's take one example. Let's represent a function. For example, if the function is f of t. F of t is a three-step function. The function is 2 if the value of t is between 0 to 1. The function is half t square if the value of t is between 1 and pi by 2. And the function is cosine of t if the value is between pi by 2 and greater, or in another word, if the value is greater than pi by 2. So we want to represent this function in unit step function. in terms of the unit step function, using the unit step function we can represent it. So this function can be represented as is f of t. So we will start from this 2 and then we'll take minus 2 times unit step function t minus 1. So this will represent this 2. Then we will take plus the second function 1 by 2 t square, and we will multiply it with the ut minus 1, and then minus 1 by 2 t square, we will multiply it with u t minus pi by 2. Okay, and now we will take the third one, which is cosine of t, and then you will multiply it with u t minus pi by 2. So this will be the representation of this function. Okay, so you will say that why. Okay, so this is actually, I just followed the procedure to write this function, and now we can verify it. So for example, for any value of t less than 1, it should be 2. So for example, this, for any value of t less than 1, this will be 0, because pi by 2 is greater than 1. Okay, so this is 0, this is 0, and this is also 0. So, and this is also 0. So therefore it will be 2. Okay, for any value of for any value between 1 and pi by 2, so this function should be equal to half t square. Okay, so this will be so any value between 1 and pi by 2, so this will be 2, and then this ut will minus 1 will be 1. So 2 minus 2, that is 0. So these two terms will be 0. That means the combined value of these two terms will be 0. How about this? Because now t is greater than 1, so this term is 1, so it will be half t square. However, these two terms will be 0, so only term remaining will be half t square. Okay, so similarly now I have shown that this one. And how about this one? So for this one, this will be 0 because it will be 1, so 2 minus 2 is 0. And how about for this? So the this u and this u will be 1, so 1 by t square minus 1 by t square, that will be also 0. But this will be 1, t minus pi by 2 will be 1, so it will be cosine of t. So therefore this statement describes this function of t. Okay, so using this methodology, you can write any function in terms of the unit step function. So what was the methodology? I repeat. So we start from t, you start from the first function and then minus the second function. Sorry, start from the first function without any unit function, but then you will subtract the same function using the first unit function with this first limits. Then you add up the second function, second component of this, and with the first unit step, then you subtract the same second component with the second unit step, which is pi by 2 over here, and then so on. You will continue it in this way. Then you can represent any any function in the form of the unit step function, because this is a stepwise function, discontinuous function. So for representing this discontinuous function, we can use the unit step functions. Okay, so we can now simplify it. Okay, not simplify, just I will collect the terms. For example, for the first component, so I will collect these terms. So for example, first component was 2, so it will be 1 minus u t minus 1. Okay, and for the second component, 1 by 2 t square, the terms are u t minus pi by 2, sorry, minus 1 by 2. Minus u t u of t minus t minus pi by 2, and then cosine of t u t minus pi by 2. So this type of format will also give you a hint how to write the function. So for example, what you can do is you can take the first function and then you will take 1 minus the first unit step function. Okay, and then second component, then first unit step function minus the second unit step function, and then the remaining one. Okay, so in this way you can also write the unit step function. Okay, so now what I want to know, what I want to do is I want to find the Laplace transform of the function. Okay, so now I want to find the Laplace transform of this function. Okay, and then for this I may be using the t-shifting theorem. But for the application of t-shifting theorem, I need to write each term of this function in terms of the shifted function. Okay, only then I can I can apply the t-shifting theorem. Okay, so which means that I will modify these functions in such a way that each of these terms will be these terms will be in the form of t minus the shifting theorem, shifting function. Okay, so what does it mean? So in this case, because this function is quite long, so I will take it term by term. Okay, so for example, if I take this term before, so in this way, here I can write it like this. So for example, I can take the Laplace of this term, 1 minus u into t minus 1. Okay, it will be the Laplace of 2 minus the Laplace of 2 times u into t minus 1. Okay, so what will be the Laplace of 2? Laplace of 2 we can easily find, it is 2 over s, because Laplace of 1 is s. So there is no problem with that, it is 2 over s. And what will be the Laplace of this? So so in this case we have the unit step function. Okay, and now I think it will be easier to write this formula over here. So f of t minus a into u of t minus a is equal to e power minus as into f of s. Okay, so this is the formula. Here, yeah, this is the t-shifting formula. Okay, so here in this case, in this function, you can see that we have t minus a, and then 2 can be also written as like this. So minus Laplace of 2, and then I can write it like this, 2 into t minus 1 power 0, right, into u into t minus 1. So in this case, now what will be its Laplace transform? Its Laplace transform will be, because it is of the same form, it will be the Laplace transform of this t function. Okay, f of s is the Laplace transform of t function. So t function is actually 1 over here. Okay, so it is 2 over s. Okay, Laplace transform of this is s, and multiplied by e power minus as, and a is equal to 1, so it will be e power minus s. So this will be, so the second term, the Laplace transform will be this. So we have found the Laplace transform of this term. Okay, I hope it is understandable. So because originally this was 2, okay, and then we have this unit step function. So we have this unit step function, we need this f of t minus a, so which is basically 1. Okay, so it should be in the same form as t minus 1. So I wrote it like t minus 1 power 0, so that will be 1. So this is actually 1. So for 1 we know that the Laplace transform is 1 over s. So this 2 is from here, and then this minus is from here, and then this one we have completed because this is the Laplace transform of f of t minus f of t, f of s, and then it has to be multiplied by e power minus s, so it should be e power minus s, because a was 1. Okay, so it said there are a lot of steps over here. Anyway, so let's look at this next term. Okay, 1 by 2 t square, and then that is being multiplied by t minus 1. But first of all we have to take some steps with 1 over 2 t square. So 1 over 2 t square we can write in this form, because we have to write somehow t minus 1. T should be replaced by t minus 1. Okay, so how we can replace it? Maybe what I can do is I can simply replace it. Okay, but then I will need to do some changes. So for example, I replace t square with t minus 1 square. Okay, so what I will have to do is, so it will be, there will be 2 extra terms, minus 2t, so I will add my plus 2t, and there will be another term plus 1, so I will have to add minus 1 over here. I will have to add minus 1 over here. So then now it is equal to, this is actually t square. Okay, however this is taken care of, t minus 1 has been taken care of, but this has to be also in t minus 1 term. So as the next step I can do it like this, t minus 1 square, and then I can write 2, and then t replaced by t minus 1. Okay, so it will be 2t minus 2, but it has to be minus 1, so it should be plus 1 over here, right? So then it will be 2t here minus 2 plus 1, it will be minus 1, and then all together it is t square. Okay, so now I have this originally I have this one. Okay, this function, so it will be 1 by 2 t square u t minus 1 is now can be written as 1 by 2 t minus 1 square u t minus 1, and then plus 2 t minus 1 into u t minus 1, and then plus 1 into u t minus 1. Okay, u t minus 1. Okay, so now I need to take their term by term Laplace transforms. Okay, so t minus 1 square is a function in t. We have run out of time for this video clip of 15 minutes, so I will continue it in the next video clip.